Hello 20-2 students. So we are carrying on with section 4.3 in the textbook, looking today at dividing radicals. So last time we started with multiplication, and now this time we're going to look at dividing. So again, just like multiplication, we can divide radicals if they have the same index. I've actually gone in and changed this number 1 in the notes that I gave you guys. I didn't like the way that was worded. So when we're looking at the steps that we would work through for here, what I would say for step number 1 is separate the coefficients and radicands into separate fractions. So you'll see that as we work through, and the fixed version is in the notes that you will see online. I just had this printed out beforehand, and with everything crazy going on right now with COVID, it's hard for me to get into the school sometimes to reprint things just for, like a little mistake like that. But the uploaded version has the proper instruction there. So then the second one, you just reduce the coefficients, basically like dividing the coefficients, then dividing the radicands, and then you can simplify. Now, in the next lesson, we're going to look at taking things a step forward when we're working with more complex division, which is where we start to rationalize the denominator. In this case, we're just going to work with kind of some more simple type of division. So in this example here, you can see these are not mixed ones, so we're kind of making this component a little bit simpler. We just have our radicands, and we just reduce them. So basically what you're doing is, if you have root 48 divided by root 6, it's the same as saying, what is the root of 48 divided by 6? Okay, so putting both of these under one radical. And so 48 divided by 6 gives us 8. So you are left with this as your answer, and of course simplify if possible. So 8 is 4 times 2. We can square root 4 to 2, which goes outside, and we're left with a single 2 there. So let's try this in a little bit more complex, which would be radicals that actually have a coefficient to them. So in this one we have, I'd say my first step is make a fraction out of your coefficient. So we have 4 divided by 12, and then we have root AB over A. So when we want to simplify these, basically you're reducing your coefficients here to the lowest possible terms. So in that case, 4, you can divide 4 out of each of these. Divide 4. 4 divided by 4 gives us 1. 12 divided by 4 gives us 3. And then when we divide our radicands, A divided by A is 1. So we're just left with root B. Okay, and so basically now we want to combine. So if we have a fraction left as our coefficient, remember this fraction is basically being multiplied by this radical, and we always multiply it through the top of a fraction. So 1 times by root B is root B, and it's over 3. Okay, so there's our final answer for that one. In the next one we have 4 over 3 is our coefficient fraction, and then under the radical we have root 54 divided by 8. So we want to reduce this fraction to lowest possible terms. Let me think here. So I think that would be, if we divide 54 by 2, we get 27, which would be 9 times 3. And then we have 8. I think that the best way to go here would be divide this by 2. So 54 divides down to 27. 8 divided by 2 gives us 4. Yeah, there's not going to be a simpler version of that. So root that and then times by 4 over 3. So now with this one, we have a little bit more complicated because our fraction isn't just a 1. So what we're going to end up with is we're going to split this back into kind of the version that we saw up here. So we're going to say 4 times by root 27 divided by 3 root 4. Now, if there's any possibility for simplification here, we would do that. 27 is 9 times 3, and 9 is a perfect square, so we can pull that out and multiply it by square root of 9 is 3, so 3 times 4 gives us 12. Root, we've taken out the 9, so we're just left with the 3 under there. On the bottom, the square root of 4 is 2, So basically we just have the whole number 2 times by the coefficient of 3, which gives us 6. Now that we have everything reduced, we want to see if anything can divide into itself. So 12 divided by 6 is 2. So essentially these numbers cancel out, and then we're left with the root 3 still there. So our final answer is 2 root 3. Okay, so lots of steps in complex questions like this. You need to really be thinking about, like, first, if you divide this and you set this up, you want to make sure that after you've simplified each individual one as much as you can, you recombine them to separate, like, mixed fractions. So these are the simplified versions. Now if you can simplify these mixed fractions anymore, you want to do that. So that's where you find the perfect square in each one if it exists and multiply it by the coefficient. Then once you have that down to your simplest version you can get it down to, that's when you can look and see if any further division can happen between the terms on the top and the bottom. So basically between the coefficients, you shouldn't have anything left that could possibly divide out of your radicands, because that's what we've been working through these steps to do, is to simplify them as much as possible. So usually you'll only be left with the possibility of division for coefficients, because they changed during this step when you simplified them into different mixed radicals. Okay, so after you do that division, now you have your final answer. Okay, last one here, 8 cube root 21 over 2 cube root 3. Same setup, 8 divided by 2, and then cube root 21 divided by 3. So 8 divided by 2 gives us 4. 21 divided by 3 gives us 7. So basically just a really nice whole number there. And we actually, sorry, that was kind of messy. 7 can't, there's no perfect cube in there. So this is just our final answer for that one. So a nice change from that middle one. Okay, so that's everything for division. You guys have a bunch that you can try here, and the answers are given to you here, but if I remember correctly, I don't think I didn't assign anything specifically from the textbook for division. So give those 4 a try. Actually, I'm just going to pause the video one quick second, see if I can find some good ones in the textbook. I don't know why I didn't put those in there. Alright guys, I remembered why I didn't put those in the first place, because a lot of them ask you to rationalize the denominator, which we will be covering in the next lesson. However, you can go ahead and complete 14 on page 199. So 14A through D, you should be able to do that with everything we learned today. So do that for some extra practice, because it is good to be comfortable with how to do this before you move forward. And I will add that into the notes as well, so that you guys will see that in your blank notes that are on the website. So I will see you in the next lesson when we learn to rationalize the denominator.